Global warming is expected to account for about 20% of the global increase in water scarcity this century. It is predicted that global warming will alter precipitation patterns around the world, melt mountain glaciers, and worsen the extremes of droughts and floods. Global water consumption increased sixfold in the last century, more than twice the rate of population growth, and will continue growing rapidly in coming decades. Yet readily available fresh water is a finite resource, equivalent to less than 1% of the water on Earth. Water and populations are unevenly distributed across the globe. Arid and semi-arid regions receive only 2% of all surface runoff, yet account for 40% of the global land area and house half of the world's poor. Finally, our existing freshwater resources are under heavy threat from overexploitation and pollution. Given these trends, equitably providing adequate water resources for agriculture, industry, and human consumption poses one of the greatest challenges of the 21st century. The physical evidence of water scarcity can be found in increasing magnitude around the world, affecting rich and poor countries alike. Nearly 3 billion people live in water-scarce conditions, over 40% of the world's population. Water scarcity is not a factor of absolute quantity. It occurs frequently in both dry and moist climates. Rather, it is a relative concept comparing the availability of water to actual use. Desert regions, for example, do not classify as water scarce if demand for water is low. However, scarcity may exist in water-abundant areas if there is heavy population pressure, excessive pollution, or unsustainable consumption levels. Together, these forms of physical water scarcity affect every continent and approximately 1/5 of the world population. On the other hand, economic water scarcity occurs when water resources are abundant relative to water use, but insufficient infrastructure or financial capacity prevents people from accessing the water they need. This dilemma plagues an additional 1.6 billion people worldwide, predominantly the rural poor and particularly in Africa, where the LFree project could make a real difference. Agriculture accounts for 70% of global water consumption and up to 95% of consumption in some developing countries. Irrigated agriculture, which accounts for only 20% of cultivated land but over 40% of the global harvest, has significant implications for the future of water availability and food security worldwide. The world's population is projected to increase by 50% by 2050. Climate change is expected to account for about 20% of the global increase in water scarcity this century. With continued population growth, increased per capita consumption, and anticipated climate change, the global water situation appears bleak. Since water scarcity is a highly localized issue determined by regional climatic and demographic factors, a single solution will not solve all of the world's water scarcity problems. However, improved management, more water-efficient technologies, and support for the world's most vulnerable countries and ecosystems will likely play leading roles. The LFree project recycles 100% of wastewater and produces 3 different water qualities according to its use. It lowers energy consumption to produce safe water and promotes renewable energy production. Please support the LFree project.